Okay, in this week we are going to discuss on text pre-processing. As we know that NLP application requires NLP data and the modeling. So, the pipeline of any NLP goes through multiple stages. There are a lot of transformation of data from one stage to other stage, only then it reaches the application. So, if you look at the NLP pipeline in common, the data is the most important aspect. So, the data collection, then it goes to text cleaning in the case of text processing stages, and the text cleaning goes into the pre-processing because the text whatever that we have collected from various sources cannot be transformed as it is to the next stage. So, some kind of pre-processing is definitely required. Then it will go for the feature engineering where lot of information on a particular text is being added as a knowledge source, and from there the data is going for a modeling. So, then it will go for different stages of evaluation, then finally we will deploy the NLP application. Then of course, the monitoring and model updation is keep happening. That is how we are trying to get any of the application, right. So, now let us see in this lecture about different ways of data collection methods and text cleaning and pre-processing techniques. Okay, let us start with data collection. So, now in NLP, the data that we are working is the most crucial aspects, right. So, we try to gather data from different sources. So, when we take the text processing as our main goal, the text data from various sources such as websites, books, articles and social media and whatnot, wherever the data is available which can be utilized for any kind of processing, we will collect the data. And these data are collected. During collecting this particular data, we also go through different kind of challenges. It is not that we are copying and pasting from one particular website or a book that can be taken for our further analysis and modeling part. So, there are a lot of challenges that are involved in this data collection. Let us start by looking at one by one. One is data quality, right. So, these data what we collect are nothing but representation of that particular language. So, it represents that language, it means the quality of the data is very much important, right. It should not represent some gibberish or some ungrammatical or unaccepted form of that particular language. So, data quality concerns a lot of things. Any incomplete and missing data will always there when we are collecting the data. Let us say we are trying to collect the data through some kind of crawling techniques and automatic techniques to crawl the data from different places. So, definitely it might fail due to different technical and code issues. So, we might end up in getting incomplete and missing data that we need to make sure the data is a complete one. And there is an inconsistent data formats. As we all know that when we are working with the data is represented, let us say in website in different format. It can be a simple HTML page or SQL page or some kind of data resource, or it is represented as a PDF or image, right, or as a video. Like there are different kind of modes of representing the data. So, there will be always an inconsistent data formats. It can be either in an editable, easily editable format, or we need to process it so that it will be converted as an editable format. So, that is another issue. And presence of noise and outliers, right. So, when we are trying to take information from again a website, we know that website is filled with lot of information, and these days lot of advertisements, lot of other highlights of other information or some kind of predictions that people try to look at what we are actually trying to query in the internet. So, those things are being highlighted here and there. So, now cleaning all these things are very important to get the quality data. Okay. Now comes the data privacy. Because can we just select the data from any website and start using it for our analysis or for our processing? Definitely no, we cannot do that thing. We cannot just copy paste the information from anywhere. So the privacy is the most important step again. So we have to ensure that data anonymization in some cases, because if the data is open source, again there are some data which are very very difficult data, which you cannot just openly say what the data is about if it has some kind of sensitive information. So sometimes data anonymization is most important thing, and it has to comply with regulation, right? So the regulations like general data protection regulations, which ensures that we cannot just copy as it is from any website. So there are some license, CC by license kind of different kind of techniques are there, which we need to follow to make sure that it complies with the regulation. And securing data storage and transfer is another problem. Again, we cannot just copy paste in any of the place that we have. We need a secured place where we can store the data, and whenever required we have to able to get the data done. Okay, and another challenge is data accessibility. Once we collected the data and cleaned all the challenges from there, and how are we going to access it? So because we cannot access all kind of data. Some of the data from various sources are proprietary or they are sensitive data, right? So that will be again another challenging factor when we are working with. And high costs for acquiring certain data sets. For example, when you want to work on a, let's say, defense sector, the data on defense sector is not so easily available, right? So getting that data is really difficult. Similarly, if we are working with any health related data, none of the health data are openly available because there are a lot of privacy issues in that one. So how to get such kind of data is another factor that we have to keep in mind. And technical barriers to accessing data from various sources may also arise. Okay, now volume. How much of data we need? What kind of variety of data we need to get, right? So when we are talking about data variety, it should be representation of that language and different kind of variety of speakers, and in terms of speakers, in terms of geographic location, in terms of different kind of age groups, in terms of different kind of gender representation should be there. So now how much of that data is required? That has to be first, we make sure what kind of application we are working on, and that particular application required what kind of volume of data and variety. So managing large volumes of data is a really challenging thing. So because NLP these days requires big data, right? And integrating this data from multiple sources and formats, and again handling all the unstructured data is also a difficult thing when we are collecting the data set. And important aspects in NLP these days are bias and representativeness, right? So we should ensure that the data is a representative of the population, and also it avoid some kind of bias, right? And addressing any inherent biases in the data collection process. If there are any inherent bias, we should know how to mitigate that data and make it as a quality data. So as we long for quantity in data size, that means big data size, at the same time we cannot get away from the quality of the data. So quality matters a lot. Again, when we are working with a low resource scenario, though we don't have a high quantity data, we want to make sure that there is a high quality data. That makes a difference when we are working with any NLP application. Okay, let's say we have collected data from various sources, and all the issues in terms of the license, in terms of the different formats and varieties are all been taken care. So now we have a good amount of data. Now, can we just use this data in building an NLP application? Definitely no. We need to do some kind of cleaning and also pre-processing. These things are very much important to go into the next stage of our data modeling. Now, what is this cleaning? What kind of cleaning we need to do? So, cleaning starts with punctuation, numbers and any special characters which are sometimes a noise for our next processing. So, for example, when we have a sentence like hello, this is an example text with numbers 1, 2, 3, 4, 5 and symbols with some symbols. Now, when we are processing this data, sometimes these numbers and punctuations and special characters might not be required, right? So, we need to remove them so that the data looks like very clean, and also there is no other foreign elements that are not required for processing our data in the later stage. Okay, remove that, of course, it helps us in focusing on only meaningful part of the text. Okay, and second text cleaning that we need to rely on is correct spelling errors and normalizing the text, right? So, when the text that we crawl from different sources are written by actual human, we all tend to make mistakes when we write. So, there may be some kind of spelling mistakes, there may be a grammatical mistakes, there may be a coherent issue, right? There may be some other issues when we are writing the text. Now, all these mistakes that are done by the human has to be at least cleaned when we are working again with a low resource setup. So, when we are working with a high resource setup, the frequency of that spelling mistake might not be statistically very significant. So, machine might not give weightage to such kind of thing. But when we are working with a very low resource setting, and if the mistakes are like even smaller in size, that has create impact on our modeling stage. So, for example, this sentence contains spelling error. So, now looking at this sentence, we know the sentence has a spelling mistake as well as spelling has a spelling mistake, right? So, there is no E here, similarly there is no L here. Now we need to correct it so that when it goes for any text representation, for weighing this particular text into some kind of like either it is a word to wake or a glow or any other contextual embedding requirement, it goes with the proper weightage. Now, so this normalization again involves converting the text into standard form sometimes. For example, when we have languages which are spoken by different kind of dialectal speakers and different kind of variety of languages, so people tend to use different kind of spelling variations. So, for example, color can be written as C-O-L-O-R or C-O-L-O-U-R. It has to be normalized in one stage when we are working with a huge amount. Again, that helps us in making sure the data is represented in a proper way. And handling misspellings, slang and abbreviations, of course, as we tell, that's all important. And for example, the original text comes from a social media. So, in social media, the language that are used is not the same as we normally use the language in real formal or informal situation, in the real time, like when we are talking with two human being. So, this kind of text need to be normalized into the normal text. For example, OMG, it has to be rolled as oh my god, and this text, for text we will abbreviate it as TXT, so it has to be changed into TXT, and great, GR with 8 marker, so that is GRE8. So, this kind of slang and abbreviated information is being required sometimes to convert into the normalized text. Okay. So, converting this one will give us, okay, it ensures the clarity and consistency across the data set. So, when you are working with a particular problem with a particular domain, we may want to make sure there is some kind of clarity and consistency. Okay. Now, let us go to the text pre-processing. We have collected the data, now we have cleaned the data. Now, what kind of pre-processing techniques we need to employ? Now, the pre-processing is again a multiple stage of like task. Once the text is be given, we have identified the noise, we have removed the noise, we have done some kind of normalization and also data masking, because we have to make sure that some information should not get into the modeling part. Once this data cleaning is done, it will go for like some kind of processing. The processing starts with some tokenization and some other high level linguistic representation like Peirce tagging, lemmatization, named entity recognition. So, in between there are many more methods which we are going to discuss right now, and also we will be talking about the linguistic processing in the next few slides. So, finally we are preparing the text, that means it is ready to go for the modeling. Okay. Now, why this is important? Is it important to pre-process the text, or once the noise is being like removed, can't we go and like start working on the modeling? No. In certain cases, pre-processing plays a very important role because it improves the quality of the data. So, now how is it going to improve the quality? Because any clean and well processed text improves the performance. Especially when you are working with some kind of task like parsing, named entity recognition kind of thing, and reduces noise because some kind of removing of unwanted letters or unwanted words from the text actually enhances our task, especially stop words. I will talk about stop words in a while, and it facilitates consistency. Right. So, some of the normalization techniques ensure that there is a uniformity in text, so the data is better understandable and so that it will be better analyzed, interpreted and generated. And also it improves the training efficiency because pre-processed text speeds up our training by reducing its complexity and dimensionality. And it boosts model quality too, because any clean and standardized data helps in learning more accurate language patterns. And it mitigates bias in certain cases because proper pre-processing and understanding what kind of bias the data has, if we are able to remove them, it reduces the bias that are present in the raw text. Okay. What kind of steps we need to follow now? Because text pre-processing is again a kind of like lot of tasks that has to be done under this particular area. So, it starts with tokenization. So, it's tokenization, it's nothing but splitting the text into individual words and sentences, and lowercasing, especially in languages like English, when there is a difference between lowercase and uppercase. So, it converts all the text to lowercase, so it ensures some kind of consistency. And stop word removal, it eliminates some kind of common words like and, the, or some of the functional elements which have very little value, that will be removed. And normalization, it converts the text into a standard format so that other inconsistencies and variations are being taken care. And stemming and lemmatization, it reduces words to their base and root form. So, now the pre-processing steps involves proper tokenization, lowercasing, stop word removal and normalization and stemming or lemmatization. Now, let us see one by one what are these steps involved. So, tokenization is nothing but we are splitting the text, that means the clean text that we got, into sentences and into words. Why is it important? Now, it's important because when we are handling with multiple elements, and again language, especially in the text, we have some kind of sentence boundaries, and these sentence boundaries are expressed through some kind of punctuation. So, the punctuations like dot or period, this period is not only representing the sentence boundary. Sometimes it is used in some kind of abbreviations like let us say PhD, ph dot d, or doctor, dr with dot. Now, these periods should not be identified as a sentence boundary, right. So, there is a big challenge now. Now, we need to have differentiating these periods in abbreviations and sentence boundaries. Also, dealing with sentences that include any quotes and parentheses, that should make sure that it is part of the one sentence. It should not be split into multiple places. Not only that, there are some example I try to give here. See, there is an original text this original text has lot of punctuation, and these punctuations, not all punctuation, are periods here represent the sentence boundary. For example, Dr. Indu, comma, an expert in AI, comma, visited Chennai, dot, right. Similarly, there is PH dot D dot and example E dot G dot, right, and we also have Marina Beach in the quote, right. Now, this particular text, if we are actually converting into sentence tokenized text, we want to make sure that the commas over here are part of the sentences, and the doctor with dot is actually a part of the sentence, but it is not a sentence boundary, right. So, doing this kind of analysis gives us to make sure that this particular text is being converted into 4 sentences. Similarly, word tokenization is again very important because it splits the sentences what we have already got into individual words. Again, splitting the text is not so blindly we can do, we again have to put some kind of effort in doing that one. The next tokenization process is word tokenization. It is a process of splitting the text into individual words. Now, we can't just blindly remove any punctuation because again the periods, that is a full stop, are ambiguous, right. So, now the doctor dot or M dot P dot has Master of Physical Health or PH dot D dot philosophy of doctorate, all this information should be actually make sure we are not splitting into different words because they are part of one particular like word boundary. Similarly, email addresses, URLs and others, alphabets, numbers and special characters have its own value, and it should be make sure that how we are able to like what is the plan of splitting it in the whole entire like text processing, that should be identified initially. And languages like English use lot of contractions. For example, VR will be written as V apostrophe RE and I am will be written as I with apostrophe M, right. So, in this tokenization approach, we have to make sure like in certain cases RE is a different token because that is a verb. Similarly, apostrophe M is a different token because again it is a verb, right. When we again representing them only RE and M, sometimes it looks like meaningless. We might need to normalize it as RE into ARE and M into M, right. So, this type of process is also be part of the word tokenization technique. Okay. Now, we have done the sentence tokenization, we have done the word tokenization. Now, how this tokenization what we are talking here is only for the text processing, but when it goes to the language modeling part, each of the language modeling technique uses different kind of tokenization. Sometimes the tokenization will not go along with the linguistic acceptance of a particular language. It might be something like it introduces some kind of alien picture. For example, if I give us something like individual. So, now individual we will make it as one of the units in the tokenization, right. But if you look at another word like let us say disestablishmentarianism. Now, look at this word is the lengthwise the biggest word when you compare it with individual. Now, can this be part of one token? Right. So, what happened in the current language models, they have some kind of tokenization technique where they create the word, they split the word into subwords. So, the subword are not exactly, need not be a meaningful element. So, they can split either in the case of T or in somewhere here or somewhere here, somewhere here, and these subwords are more or less the kind of like frequency of occurrence in that language. If DI is more frequently being used, it will be called as one of the subword, right. So, now these subwords are alien words in that language because they are not actual words, right. So, this is a different rich technique that people are using for language modeling. So, we will talk about it in detail in the next few classes. But here in this particular session, the tokenization, what we mean is we are splitting the word into meaningful element. Okay. Now, let us go to the another text pre-processing stage, that is called lowercasing. It is very important in languages like English. Of course, in Indian languages, most of our languages do not have the difference between lowercasing and uppercasing. So, now the lowercasing, it's nothing but it's a process of converting all characters in a text into a lowercase. Why it's important? Why can't we just work with uppercase and lowercase as a different character? And we know that in Unicode representation, each of them have a different Unicode value. So, if we change the Unicode value, will it change or affect anything in the language production? Of course, that we have to think about it. Now, uniform representation is always good when we are working with bigger data, because treats the words in different cases as identical, because which are crucial in the accurate text analysis and processing, and it simplifies our matching, and it improves our model efficiency, because when the data is consistent, it enhances the performance in a massive way. So, for example, when you take a sentence like the quick brown fox jumps over the lazy dog, let us say it is written in this way, right. Normally, we do not write, because fox and dogs are not actually proper nouns, or they are not the starting of a sentence. So, most of the time proper nouns and the starting of the sentence is written in uppercase, and abbreviations and other special mentions are being used with an uppercase. But in, let us say we have a sentence which are written like this. Now, if we convert them, so now capital F is changed into small f, and this DOG is again changed into smaller thing. So, what is the use case? Why do we need to do that? Because when we are working with, let us say, a search engine, so we are querying for quick brown fox, but in a database there is no B with capital letter and no, let us say, no F with a small letter. Now, this will create a problem. Now, when we are querying, again we need to have a lowercasing. So, similarly, when you are retrieving, we want to make sure that the text is in the lowercase. So, this ensures the search result better match regardless of the case used in any of the documents. So, this is also one of the pre-processing technique. People use it in more massively for different kind of NLP technique. Okay. Then what else? So, other pre-processing technique that is more important here is again stop word removal. Again, it is depending upon the application. So, what is stop word? So, stop word actually nothing but it eliminates the common words that add little value to the text, something like functional elements like and, the, of, in kind of thing, and it is again depending upon the application. Let us say when we are working with any kind of parsing or machine translation or any other higher language understanding, these functional elements carries lot of value. So, in such cases we cannot remove the stop word. But let us say we are working on something like chatbots or retrieving the information or summarization kind of techniques. Sometimes the stop words are repetitions which need not be given much importance. So, again it is depending on the application, we will select whether we need to remove the stop words or not. So, now the challenges in doing the stop word removal is we are determining the appropriate stop word list, right. It changes according to language. So, in all languages we might not have the same kind of stop word, and because for a particular context stop words are something different, in another context stop words would be different. So, especially for information retrieval, sentiment analysis and topic modeling, this kind of NLP techniques require stop word removal. So, it ensures that sometimes we cannot just remove anything as stop word. For example, when you have important words which are not mistakenly removed, for example, no, in no pain, no gain, if you remove no, then pain and gain, right. So, that is what we might get. So then when to not remove stop words? So if the task involves understanding the whole context or sentiment, so you cannot just remove the stop word just like that. For example, words like not are very important because it carries lot of sentiment, right? So when you say not happy, if you remove not, it will become happy. So it's an opposite to the whole sentiment we are talking about, right? So they are very crucial in understanding the sentiment. So for tasks like machine translation and text generation, retaining these stop words are very much important because it preserves the grammatical structure and the meaning of the sentence, right? So because when you say something like I went home, this sentence is perfectly all right, but when you say I went school, you cannot say that, you have to say I went to the school, right? So in this case, to is very important factor because it gives you the destination. But in the case of English, that home may not require the marker to, right? So there are contexts in languages where to use a functional element, where not to use the functional element. But when you look at these two construction, they are like similar kind of thing. There is an agent and there is an action of going and there is a destination. So I is an action, going is an I is an agent, going is an action, and home or school is the destination. But depending upon the word, the selection of the case marker, right, the preposition is very important. So that we have to make sure when we are generating the language, we want to make sure it generates the language as equal to the human generates. So for that, stop words play a very important role. Okay. And on the other hand, multi-word expressions, they are called as MWEs. Sometimes there are set phrases which always collocates together. So these kind of expressions like fish and chips, kick the bucket, they lose their meaning when the stop words like and they are removed. So we want to make sure in such cases we cannot remove the stop words. So again there is a big challenge here. Okay. Now, let us say now we have tokenized, now we have removed or lowercase the thing and we have removed the stop word depending upon the application we are working on. Now, the another important step is normalization. So, normalization involves converting the text into a standard format such as again lowercasing and expanding some of the abbreviation and correcting some kind of spelling errors. So, now handling variations in spelling are always challenged, which one to select, right. So, again it is depending on what kind of application and who are the people we are working on. So, that require us to select which kind of spelling we need to make sure is represented in the text. And dealing with domain specific abbreviations and slangs are very important, and correct spelling errors without adding any new errors are important aspect of normalization. So, for example, if we are giving a text like lol, that was the funniest joke ever. So, now LOL might be there only in again social media kind of text, right. So, now it has to be expanded as laugh out loud. So, that was the funniest joke ever. So, this gives us a broader understanding on what this particular abbreviation means. So, this normalization again can be looked at in different ways. One is Unicode normalization. So, Unicode normalization is nothing but, we know in every language we have lot of glyphs. Glyphs are nothing but the characters, right. So, every language has characters. For example, Hindi is written in Devanagari, similarly Sanskrit, Marathi and other languages, right. And if you take South Indian languages, Tamil is written in Tamil script, Telugu is written in Telugu script, Kannada in Kannada script, Malayalam and Malayalam script, right. So, similarly Odia has another script, Bengali has its own script, Punjabi has again Gurmukhi, and Santali has something like Oljiki, right. So, we have different kind of writing system in India, and most of the other languages may use Romanization technique, that means write it in using the Roman letters, or like try to adopt the language writing system which they are living nearby. For example, when people in let's say Badaga speakers who are living in Ooty, so they want to write Badaga, then they try to adopt Tamil which is being spoken nearby that particular place. Right. So, similarly, we make sure that there is some kind of textual representation in some languages, but still oral representation, oral culture, orally using the languages is much more like higher when you look at the textual thing. Now, this textual again when it is represented, sometimes there are some kind of ambiguities. These ambiguities are the glyph, that means the representation of the particular sound, two different sounds are represented by single like glyph. For example, this let us say ka with there is kind of nukta marker, and this nukta marker has can be written in two different ways. One is again already in the Unicode there is a representation of ka with nukta with a code point. Right. Sometimes it's also can be written with two different code points, one is with ka with another nukta as a separate value. Now, when we have this kind of two different representation, that means one with this code, another with the combination of these two codes. Right. So, 0958 let us say represent ka with nukta as one character, and 0915 plus 093C represents like ka and nukta represent respectively. So, now when we are working with text like weightage later, what will happen, this will get a different weightage and this will get a different weightage. Now, normalizing this one into one particular value might help us to make sure that there is a uniform and consistent representation across the document. And spelling normalization is another important thing. For example, the Telugu word, that means taruvata, taruvata means later or afterwards kind of meaning it can give. So, this particular word can be written in multiple ways. It can be written as taruvata or tarvata or taravata, right. Which one to be taken? So, the spelling wise people write it in different ways. So, normalizing it with one spelling also adds on value to our whole representation later. So, spelling of these kinds might be valid, but most frequent in corpus are taken. So, that will be used as a normalized technique later for the processing. Okay. And stemming and lemmatization is another type of pre-processing. I will give a small introduction here, but I would like to talk in more deeper way how this stemming and lemmatization are done when we are working with linguistic representation. So, now what is stemming? Stemming is a process that removes suffixes from words and so that it reduces them to a base form, and it uses some kind of heuristic rules and does not always produce valid dictionary words. And lemmatization on the other hand reduces the words to their base or a dictionary form. The dictionary form is nothing but lemma. The root word that we see in the dictionary is nothing but a lemma. So, it considers the context and ensures that the root form is a valid word. So, in isolation you can use it and it is still a meaningful acceptable form. It involves more complex analysis compared to stemming. Okay. Now, the examples are when we have a set of words like in English flies, flying and flight. So, as you say the common letters, if you pattern match them. So, the common letter is FL, FL and FL, right. So, and within these two words FLI is the common representation. Now, the stemmed form is either FLY or FLY here for this particular case. Now, if you take FLI, it will not be seen in any of the dictionary. It is not part of the lemma in any of our dictionary, and it cannot even occur in isolation, right. So, the stemming is nothing but reduce, that means remove all kind of extra grammatical information which are called as inflection from the word and take only the remaining part. Whereas lemmatization, for example, again when we take the same three words, flies, flying and flight, so now the lemmatized form is fly, that means we are reducing this word into a root form. Now this root form, what we see in the dictionary, what we normally used in isolation as a meaningful element. So now stemming and lemmatization have two different kind of understanding. Now again when you take a word like ladies, now when we stem them, the stemmed output is LADI, reducing the ES as a plural marker, and the lemmatized output is LADY, right. So now how is it useful? Now the useful is nothing but when we are querying this kind of words, especially in information extraction kind of thing, only removing the excessive like no functional element gives us the stem that can be taken and queried or searched across the document. So that will give us some kind of output. But converting them into a root word is a long process that requires some kind of linguistic knowledge. So we will talk about it in detail in next few lectures. So stemming uses heuristic rules to strip suffixes. That means if we can identify what kind of suffixes language has, we can easily identify them, whereas lemmatization uses a dictionary and also context. So stemming can produce non-words, that means you will not accept it as a word in isolation, but lemmatization produces valid words. Though the complexity is lemmatization involves more sophisticated analysis, sometimes the more accurate, but on the other hand more expensive than stemming. Okay. Now when you look at all this process, when we take the text, like how to collect the data, how to clean the data and how to pre-process the data, all these things are very important because the data is not just taken and transformed into a model to make it as a language representation. So now the importance of text processing is it's helps us to make sure that the data is clean, consistent and ready for any kind of analysis. The key important steps are collecting the data, cleaning the data and do some kind of pre-processing techniques. So the challenges, of course, in each of the stages there are challenges which we have already discussed. So making sure the data is handled without any noise, the privacy is ensured and different kind of text formats and biases are being removed. Now adapting the pre-processing steps to any of our requirement of NLP is important. So it helps us in maintaining integrity and meaning. So the future direction of any NLP involves keeping up the advancement in pre-processing techniques. And when we are talking about tokenization, we just discussed only about the sentence tokenization and word tokenization. But again, the most important pre-processing tokenization techniques like bag of words or stop words or another byte pair encoding techniques which we have discussed, not discussed here, but we will be going to discuss later. So this kind of techniques are very important because these tools are helping us to improve the accuracy and analysis of the text analysis. Thank you.